There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air, with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the signs, sodium for salty times, magnesium.
Really confused, and this is my problem. I have the equation down here. It's 40.0 grams of iron oxide reacts with 10 milligrams of magnesium. What is the mass of iron produced, and what is the limiting reactant? So like you show here, iron oxide plus magnesium yields to iron plus magnesium oxide. So we're going to start with our units given, which we have 40 milligrams of iron oxide and 10 milligrams of magnesium. Okay, then we find the unit factor, which will be the molar mass. 1 mole of iron oxide will be, as we have here, our periodic table, 55.85, which is a mass of iron, and plus the molar mass of oxygen will be 71.85 grams of iron oxide. The next step would be to use our molar ratio, which will be 1 mole of our iron over 1 mole of our iron oxide. And the next step will be to find the grams of iron, in which we know that the molar mass of iron would be 55.85, and that would equal 1 mole of iron. At this point, we could do elimination. And then we'll do our calculation. I solved the problem, and I just want to show you how I got that. Basically, when I did the cross multiplication, I did the 40.0 grams times 55.85 divided by 71.85, and equals to 31.09 grams of iron. Okay, so now we'll start my next problem. We have to find the mass for iron and magnesium. So as you can see, I used the same problem. Basically, what I wrote down here was grams, moles to grams. It's an easier way to kind of break this down. So we'll start with our mass of magnesium, which I have here is 24.31 grams of magnesium. That will be 1 mole of magnesium. The second part, remember, it's the molar ratio. We'll have 1 mole of iron over 1 mole of magnesium. Okay, and over here, we'll have the mass of iron, because that's what we're wanting to know, which is 55.85 grams over 1 mole of iron. Okay, and we'll do the elimination, and I'll get the problem. For our magnesium, so what I did is I did elimination. 10.0 times 55.85 divided by 24.31 equals 23 grams of iron. At this point, you could tell which one's your limiting reactant, which will be our magnesium. This is our iron oxide. So we'll say that magnesium is our limiting reactant. That's my video.
Number 63, and if 1 gram of magnesium hydroxide reacts with 0.605 grams of sulfuric acid, what is the mass produced of magnesium sulfate and the limiting reactant? This is our equation, but I had to balance it because there was 2 O's over here and there was only 1 there, so I put a 2 there, and now it's balanced. So you're going to put the given, which is 1 gram, right here, and it is of magnesium hydroxide, which is MgOH2. And and then you're going to find the molar mass of this, because you have to do the unit conversion. And then you have magnesium, which is 24.31. Hydrogen is 0.01, and there's 2, so you multiply that by 2. And then oxygen is 16 times 2, and then you get 58.33 grams of magnesium hydroxide over 1 mole of magnesium hydroxide. And then you're trying to find magnesium sulfite, so then you're going to have 1 mole of magnesium sulfate over 1 mole of magnesium hydroxide. And then you're going to find the molar mass of this. 38 grams of magnesium sulfite over 1 mole of magnesium sulfite. And then you're going to cross cancel. So the magnesium hydroxide cancels down here, and then cancels up here, 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 here. And then we'll do the calculations. The calculations, we do 1 gram times 120.38 grams of magnesium sulfate over the molar mass of the magnesium hydroxide, and you get 58.33 grams, and you multiply, and then you divide, and you get 2.1 grams of magnesium sulfite. Now we're going to the next and the magnesium sulfate that was produced with the 0.605 grams of sulfuric acid. So you put the given 0.605 grams right there, and I have to find the unit conversion, so you have to find the molar mass again of sulfuric acid. So you look at your periodic table, you crunch some numbers, and then you're going to get 98.08 grams of sulfuric acid, which is H2SO4. And then this is H2SO4 grams of that. And over 1 mole of H2SO4. And then you have to do another conversion, another bridge, and then it's going to be 1 mole. And then you're trying to find the magnesium sulfate again. So MgSO4 over 1 mole of the sulfuric acid, H2SO4. And then you're going to take the molar mass of Mg sulfate again and plug it in right here. Over 1 mole of magnesium sulfite. And then you're going to plug and chug. So you're going to plug and chug the 0.605 grams times 120.38 grams of magnesium sulfite divided by the 98.08 grams, and you will get 0.742 grams, and then you're going to compare the two, and you realize this is smaller, so this is your limiting reactant, which is sulfuric acid.
Okay, so this is my limiting reactant problem. If 1 gram of aluminum hydroxide reacts with 3 grams of sulfuric acid, I think it's sulfuric, just kidding, what is the mass of water produced? And then later we're going to find the limiting reactant problem. So the first thing I needed to do in my equation is I needed to make sure it was balanced, which it wasn't. So in order to balance it, I looked at both sides and realized I needed to put 2 to balance out my aluminum, 3 to balance out my hydrogens and my oxygens, and then 6 over here to counteract that. So now that I have my equation balanced, I can now go in and start to do my conversion factors. So first thing I'm going to do is I'm going to start with 1 gram And we're working with aluminum hydroxide. So aluminum hydroxide. Now here I'm going to have my mass, my molar mass, sorry, which we're going to be able to get off the periodic table, and you can find those on any periodic table. You just want to look for the mass, and then you need to be sure that you're multiplying properly. So OH is going to have 3, aluminum is going to have 1, that sort of thing. So basically, we're going to have 1 mole of OH3, and that is equivalent to 78.01 grams. And then just so I don't get confused, I put this down here, just to remind me where I got that number from. Makes it a little bit easier. So since we need this mole to cancel out, it kind of helps us to figure out where we need to go. So it's going to be 1 mole aluminum hydroxide. And this is asking for water. So the next thing we're going to do is we're going to convert to our moles of water. And here's where it gets a little tricky. According to the balanced equation that we have, we know that our products, there we go, is going to have 6 water molecules. So we need to account for that. So that's where the 6 is going to come from. But now down here, it's not going to be just 1 mole because we're applying this to our equation. So this is actually going to be 2. And once we have that, then we can balance out just 1 mole of water. By using the periodic table again and making sure that we balance this out. Now just for 1 mole, we're not multiplying by 6, we're just going to do the 1 mole of water. And that's going to give us 18.02 grams of water. So this part's pretty easy. You just want to go through, get rid of everything you don't need. Don't forget the grams here. And then your moles will cancel out. And then we'll do our calculations. Now we're going to do our calculations. And you want to make sure that everything goes in the proper order, just so that you make sure you don't miss anything. So you have 1 gram, 1 times 6 moles, but we're not writing the moles, we're just writing the numbers. And then 18.02. Now this gram we can put into our equation because we haven't canceled that out yet. And that's all going to be over 78.01 times 2. Okay, and that's going to give us 0.693 grams of H2O. So we're going to leave this here so that we can compare it to the next one that we're going to do, which is going to tell us which one of these is going to be our limiting reactant. So for the second part, we're actually looking for sulfuric acid. We want to see how much reacts with sulfuric acid so that we can find our limiting reactant. So we use 3 grams of sulfuric acid. Again, write this in so you don't forget it. And pretty much it's going to be the exact same formula or equation, conversion factors, however you want to call it. It's just that our molar mass is going to be the one distinguishing factor. So we're going to have 1 mole of SO4, and then the molar mass of SO4 is going to be 96.077 grams. And then we need to get rid of our mole, so 1 mole SO4, and then again we're going to do moles of water. And at this part, we're actually going to convert back not only to our balanced equation, but also to this up here, just to kind of remind us where we're coming from. So it's going to be mole, because we only have 1 mole of SO4 on this side, but we still have the 6 moles. So you need to account for that. And then to get rid of this, our moles of water, and then the weight, the molar mass will be the same. 2.02 grams each. H2O. And then here we can start to cross everything out. So again, grams, grams, SO4, 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 H2O, H2O. Now leave this with our numbers. And then from here, we would just write 3 times 6 times 18.02 grams H2O, which you can leave because that's what we're looking for, divided by 96.07. And that is going to give us 3.376 grams of water. So because aluminum hydroxide was less, this is going to be our limiting reactant.